Given an equation with two variables, an ordered pair solution is a point that when I plug it into the equation, it makes a true statement. Now what we mean by that is if we look at the ordered pair 0, 4, and we plug in 0 for every x coordinate in the equation and 4 for every y coordinate in the equation, if it then turns out to be a true statement, then we say yes, it's an ordered pair solution. So let's do that here. Our equation is y is equal to x squared plus 5x plus 4, so we'll plug in y is equal to 4 for the y variable in the equation, so we'll have 4 is equal to, and then we'll have x squared plus 5x plus 4, plugging 0 in for those x's. So let's open up variable holes for those x values. This would be x squared, 5 times whatever it is we plug in for x, and then plus 4. So we've basically just recopied the equation, replacing these x's with holes so that I can plug x is equal to 0 into those spots, and then we evaluate. So we have 4 is equal to 0 plus 5 times 0 is 0 plus 4, so this is 4 is equal to 4, which is a true statement. So since plugging 0, 4 into the equation made it true, then we say yes, the ordered pair 0, 4 is an ordered pair solution. Now let's do this one more time with another ordered pair. This time we'll be plugging -1 in for the x's and +1 in for the y's. And so we have y is equal to, we'll plug +1 in for that y value. Since this x value is being squared, I'm going to open up a variable hole to be sure that I square everything that is being plugged in for that x. When we have that variable hole, we can be sure that the entire quantity of x is being squared. That means the negative and the 1. And then we plug -1 in for this x value as well, and then we evaluate to see whether or not this is a true statement. So here, since the negative and the 1 are both being squared, this quantity is +1. Now we have plus 5 times -1. 5 times -1 is -5, so this is going to be -5. And then we finish off with the +4. Let's just bring that down to keep our calculations nice and clear. So now we have 1 on the left-hand side still, and then 1 minus 5 is -4 plus 4, which is 0. Now this is not a true statement, and since plugging -1, 1 into the equation yielded a statement that was not true, we'll say this is not an ordered pair solution to the equation. Now we're going to use the table feature on a graphing calculator to find 3 other ordered pair solutions to the equation. We're looking at a TI-84 Plus here, and in order to find ordered pair solutions, we first need to input our equation into the y equals field. We'll input it by saying x raised to the 2 power. Coming out of the exponent, then we say plus 5x plus 4, and then we'll enter to input that equation. Now, the table feature on the calculator is here in blue above the graph button, so in order to access that, I'm going to have to hit the second button. And when I do that, I see that I get an arrow in the cursor indicating that all of the blue functions on the top of the keys are now activated. So when I hit the graph button, I'm actually accessing the table function. And here is where we can see a lot of ordered pairs that are ordered pair solutions to that equation. Notice we see our point 0.04 that we already tested algebraically, but we also see lots of other points that could be plugged into the equation that would also make a true statement. So let's just see that -1, 0. If we were to plug this ordered pair into our equation, we'd be plugging 0 in for y and -1 in for each of these x values. So we get 0, +1 minus 5 plus 4, and this time 0 does equal to 0 on the right-hand side, indicating that this is an ordered pair solution. When an ordered pair is an ordered pair solution to the equation, it's also a point on the graph of that equation. And so 3 more ordered pair solutions coming from the table feature of the calculator would be, let's say, -3, -2, -2, -2, and -1, 0. We could also say 0, 4 is an ordered pair solution, 1, 10 is an ordered pair solution, so we could keep going, but we were only asked to find 3. So now let's bring a couple of those ordered pair solutions down to the Cartesian plane, whereas you'll recall this is the x-axis, the vertical axis is the y-axis. And so when we want to graph an ordered pair, we're going to go -2 in the direction of x and then -2 in the direction of y to land at our first ordered pair, which is at -2, 2. To graph the second ordered pair, we go -1 in the direction of x and 0 in the direction of y, so we land here at the ordered pair -1, 0. Let's graph 0, 4, which is 0 in the direction of x and 4 in the direction of y to land here at this ordered pair. And instead of doing 1, 10, let's actually go back the other way, since that point is going to be off our screen, and let's look at the -3, -2 ordered pair that we had, which is 3 in the direction of x and then 2 in the direction of y to land down here. And let's actually grab one more from that table before, which is -4, 0, to give us 4 in the direction of x and 0 in the direction of y, which is this ordered pair here. Now, our graph is starting to take shape, but what we would see if we continued to graph all of the ordered pairs that are ordered pair solutions to the equation, that collection of points graphed on the Cartesian plane would connect to give me the graph of the equation. So the graph of a two-variable equation is simply the collection of all of the infinitely many ordered pair solutions that are going to give us true statements when we plug those points into the equation. And because there's infinitely many of them, they're so close together, we actually don't see any space in between, and that's what gives us the graph itself. So now if we were to come back to our calculator in that y equals field, and this time instead of hitting the table feature, we actually just hit the graph button, we see that we get a parabola that matches what we were able to achieve by hand.